Aerial powerhouse the F-15EX Eagle. This modernized fighter jet tagged as an air superiority fighter boasts unprecedented capabilities that has left both Russia and China shocked as the world watches in anticipation, ready to behold the power of this modernized aircraft. The new Eagle II, alongside the upcoming 6th generation fighters, promises to redefine air superiority. And dominate the skies. What are the capabilities of this air fighter? Why is the USF investing in more F-15EX? Join us as we unveil the USAF's new the F-15EX, equipped with capabilities that have shocked Russia and China. The journey of the F-15 started in the era of the Vietnam War, where the US Air Force and Navy clashed over the future of their tactical aircraft. At the center of this debate was Defense Secretary Robert Magnum, who wanted commonality in aircraft designs despite potential compromises in performance. This initiative concluded in the TFX program, which aimed to satisfy both Air Force needs for a medium-range interdiction aircraft and Navy requirements for a long-range interceptor. However, it was just the beginning. In January 1965, MN challenged the Air Force to produce a new, cost-effective fighter that is capable of handling short-range roles and providing close air support, replacing aging aircraft like the F-100 Super Sabre, while the Navy favored robust attack planes such as the Douglas A-4 Skyhawk and LTV-A-7 Corsair II. The Air Force leaned towards the versatile Northrop F-5, which boasted secondary attack capabilities. 4 months after the challenge, Harold Brown, then leading the Department of Defense RC and engineering, advocated for exploring the F-5 and initiating studies for what would eventually become known as the FX. This new breed of aircraft was visualized to prioritize maneuverability over sheer speed and would need to pack a punch with ground attack capabilities. To be considered, the quest for an air superiority fighter gained momentum in October 1965 when the Air Force issued a formal request for proposals to 13 aerospace companies. Meanwhile, the Air Force's decision to opt for the A-7 over the F-5 for support roles further fueled the drive for an aircraft dedicated to air superiority, especially since the A-7 lacked credible air-to-air combat capabilities. 8 companies eagerly responded with innovative proposals, with 4 progressing to further refine their designs. By July 1966, the resulting concepts were formidable, with variable sweep wings and impressive speed capabilities, although they resemble the large heavy TFX F-111 and weren't yet suited for true air superiority missions. However, things got a little more complicated during Vietnam War. Studies on combat revealed troubling results. The focus had been on long-range combat using missiles, leading to aircraft designed for speed and equipped with large radars but with limited maneuverability and often no guns. The McDonnell Douglas F-4 Phantom II, used by the Air Force, Navy and Marine Corps, illustrated this approach. It was powerful and capable, but struggled in close range dogfights against smaller, cheaper fighters like the MiG-21. Missiles proved unreliable, especially up close. Improved training and adding the M61 Vulcan cannon to the F-4 helped, but early experiences prompted a re-evaluation of the 1963 Project Forecast doctrine. This led to John Boyd's energy maneuverability theory, emphasizing power and maneuverability over speed for effective fighter design. The Fighter Mafia, a group, advocated for a lightweight maneuverable day fighter, proposing a design with a near 1:1 thrust-to-weight ratio, a top speed of M2.3, a weight of 40,000 pounds and a wing loading of 80 pounds per square refoot. Meanwhile, the Navy found the F-111 unsuitable for their needs and started the VAX program for a new fighter. In May 1966, Magnum asked both services to evaluate if VFX could meet the Air Force FX requirements, and after 18 months of studies they concluded the needs were too different. The Navy prioritized loader time and mission flexibility, while the Air Force focused on maneuverability. In 1967, the Soviet Union unveiled the Mikan Gurovich MiG-25 at the Domovo airfield. Near Moscow, the MiG-25 was a high-altitude interceptor that used stainless steel instead of aluminium to achieve speeds over Mach. Stainless steel instead of aluminium to achieve speeds over Mach 2.8. This design required a larger wing to handle the high altitudes, making it look similar to the large FX studies which worried the U.S. Department of Defense. The observers feared that the MiG-25 was superior to all existing US fighters, including the upcoming FX, due to its speed, altitude capability, and endurance. The MiG-23 also raised concerns as it was believed to be better than the F-4. Both the Air Force Head Artis and Tactical Air Command W wanted a multi-purpose aircraft, but DOS and Air Chief of Staff Bruce K. Holloway pushed for a pure air superiority fighter to match the MiG-25 performance. Meanwhile, the NRV ended its VFX program and accepted Grumman's proposal for the VFX, which became the Grumman F-14 Tomcat. The VFX was closer to the Air Force evolving FX requirements. These worries led to internal debates within the Air Force, which ended with the concern that the Navy's VFA might be imposed on them. By May 1968, the decision was made that the new aircraft should be an air superiority fighter. When the American military acquired heat-seeking air-to-air missiles, they decided that machine guns on fighter jets were terribly outdated. Therefore, the McDonnell Douglas F-4 Phantom didn't have weapons suitable for close range air combat, leading to losses against the more nimble MiG-21. In the skies of Vietnam, military leaders quickly reconsidered their priorities for future fighters, giving preference to speed, a powerful long-range radar, a huge supply of air-to-air missiles, and of course a weapon for close combat. Secretary of Defense Robert McNamara asked the U.S. Air Force and Navy to join forces to create an ultimate aircraft that could be used without much modification. The service's request was responded to by Fairchild, Republic North American Aviation, and McDonnell Douglas, but the most unexpected participant in the project, even for aircraft manufacturers, was NASA. Yes, as you already understood, the U.S. authorities were serious about overtaking their main strategic enemy, the USSR, for years to come, having won the competitive selection. McDonnell Douglas began polishing the prototype, which at that time resembled a twin-tailed F-14 Tomcat with fixed wings. The result of the efforts was the single-seat F-15 and the two-seat F-15, which would later be renamed the F-15A and F-15B. The versions received new Pratt and Whitney F-100 engines instead of the initially proposed 25mm Ford Philco G7 cannon with caseless ammunition. The fighter, being faced with development problems, received the legendary M61 Vulcan. Just like the A-10 Warthog, the F-15A took off on its first flight in July 1972, and a year later its iron brother, the two-seat F-15B, spread its wings. Progress as being made, and the Eagle tried its best to stay ahead of it. In 1979, McDonnell Douglas and a F-15 radar manufacturer Hughes teamed up to privately develop a strike version of the fighter called the F-15 Strike Eagle. This became the starting point in the history of the F-15 Advanced Eagle family, and in particular the F-15EX Eagle II. In the 2010s, the U.S. Air Force was facing a shortage of fighter jets for the 2020s. This was due to budget cuts after the Cold War, and in 1991, in the focus on counterinsurgency warfare after the 9/11 attacks, the USAF had planned to buy 381 F-22s to replace its older F-15A2D Gators, but this number was reduced to just 187 in 2009. To keep enough air superiority fighters, the USAF planned to extend the service life of 179 F-15CDs to the 2030s. These jets, now known as the Golden Eagle or 15-2040C up GR-8, would get new avionics including ESA radar IST and the EPOS electronic warfare suite. Some upgrades like EPOS would also be shared with the F-15 fleet. However, by the mid-2010s, the F-15C fleet was too old and expensive to maintain, and the F-35 program was delayed. Restarting F-22 production was too costly. Meanwhile, both was developing upgrades for the F-15E for export. Customers leading to the F-15 Advanced Eagle family. The F-15 Sapphire ST flew in 2013, followed by the F-15QA in 2017. In 2017, studies showed that a mix of fourth and fifth generation fighters would be more affordable for the USAF. This led to discussions between the USAF and Boeing about the F-15EX, a single-seat variant based on the F-15QA to replace the F-15CDS. Both single and two-seat variants were proposed, called F-15CX and F-15X, with the USAF choosing the X in 2019. 8 F-15EX aircraft were included in the FY 2020 budget request. This allowed the use of the existing F-15 production line with minimal cost and supported Boeing St. Louis division to maintain diversity in U.S. fighter manufacturing. The F-15X improvements included AESA radar, IST, and EPOS, along with features from the F-15QA, such as a revised structure with a service life of 20,000 hours, new cockpit and flight controls, and the Ambassador, a system to carry up to 22 air-to-air missiles. The Boeing F-15EX Eagle II is seen as a fighter jet that can perform many roles in all weather conditions. It may not be as stealthy as the latest F-22 and F-35 jets, but it brings a powerful punch to the U.S. Air Force, designed to support these fifth-generation fighters. The F-15EX excels in homeland and air-based defense, enforcing no-fly zones and launching massive standoff weapons to aid stealth fighters at the front lines. In a bold move, the U.S. the Defense Department ordered 8 F-15X for $1.2 billion in July 2020, marking a significant investment in air superiority. The excitement peaked on February 2, 2021, when the F-15X took its maiden flight. Just a few months later, it earned the official name Eagle II. The 2021 defense budget fueled the program further, with $1.23 billion for 12 more Eagle IIs, aiming for a total of 144. However, by May 2022, the Air Force adjusted its plans, scaling back to 80 aircraft. Interestingly, the first operational F-15Xs will fly without conformal fuel tanks, focusing on agility and speed. But the story doesn't end there. The proposed 2024 budget includes funds to buy 24 more F-15Xs, setting the stage for a formidable fleet of 104 Eagle IIs. The F-15X is poised to be a game-changer, reinforcing the U.S. Air Force's dominance in the skies. One reason why the Advanced Eagle is sought after is that it included many upgrades for export customers, such as the General Electric F-110 GE-129 engine, either ALQ-239 digital electronic warfare system, and a redesigned wing structure for longer service life. It also featured an improved cockpit and a digital fly-by-wire control system, which fixed stability is SUs and allowed for 2 extra wing pylons, unlike some other Advanced Eagle models. The F-15X does not have the BAE systems and a 57 common missile warning system, although the mounting points for these NSOIs were kept to avoid changing the action process and to keep the same aerodynamic profile for the fly-by-wire system. The F-15X has advanced avionics and protective systems to improve the pilot situational awareness and survivability. Its APG-82V1 radar, a mix of older F-15 and Super Hornet tech, works with a new cooling system and tunable filters to enable simultaneous radar and electronic warfare functions with the EPA system. This digital system provides radar while warning and threat geolocation and integrates with countermeasures like the AL-47 shaft SLF flare dispenser. Both the pilot and the weapons systems officer can use the joint helmet-mounted cueing system to target weapons at high angles. The Legion Pod's IST-21 sensor detects threats passively, especially low observable on The F-15EX can be flown by a single pilot for simple missions, but the back seat is ready for a WF or more complex tasks, including working with unmanned aircraft, mainly used as an air Superiority. Why fighter to replace the F-15CD and support the F-22? It can also perform ground attacks with Lantern and Sniper XR pods like the F-15E. One important feature of the F-15X is its open systems architecture. This allows for future upgrades, which means when outdated it can always be upgraded. The F-15X can carry a large payload, offering great flexibility for air, super order or escort missions. It can carry 12 air-to-air missiles like the M120 or M9 Sidewinder, and possibly up to 16 AIM-120s, 4 AIM-9s and 2 AGM-88 HARMs, although this hasn't been tested or dead yet. For precision strikes it can carry 16 GBU-39 small diameter bombs, 4 rams, a 2,000 pounds joint direct attack munition, 2 HARMs and 2 fuel tanks. Additionally, it can carry large standoff munition like the AGM-158 JSM or the AGM-183 Arabella W, adding extra firepower to support the frontline F-22 and F-35. The advanced Eagle has a stronger structure, making it heavier than earlier F-15 models. However, its digital fly-by-wire control system and powerful F-110 SL-19 engines give it much better maneuverability and handling. This allows it to fly aggressively without worrying about angle of attack, limits the fly-by-wire system so makes the aircraft more resistant to spinning out of control and better at handling uneven weight distribution. The first planned improvements to the F-15X included ESA radar, infrared search and track, and OSS or Eagle Passy VE active warning survivability system from existing F-15 modernization programs, while combining the advantages of the F-15QA, such as a revised design with a service life of 20,000 hours, a new CKPIT flight controls, and an advanced AMBER or advanced missile and bomb ejector rack system capable of carrying up to 22 air-to-air missiles, although all these features would still not allow the Eagle 2T withstand the latest air defense systems with the same effectiveness as the 5th generation Raptor and Lightning II. The F-15X fighters could still provide excellent support for the latter and air superiority missions by arming homeland and airbase-based defense, enforcing no-fly zones against limited air defenses, and deploying standoff weapons in support of stealth fighters at the front line. The X modification takes the Biz T from previous Eagle incarnations. The engine was replaced with a General Electric F-110 GE-129 with a maximum thrust of 29,500 pounds force, complementing it with a much more advanced ALQ-239 digital electronic warfare systems to replace the previous ALQ-1228 electronic warfare warning set, which was part of tactical electronic warfare systems. The appearance of the Eagle also underwent changes. Engineers evaluated the design of the wings and greatly improved it, increasing the service life of the device from 8,000 to 20,000 hours. Additionally, there was a place for those innovations that were previously proposed for export but never found a response from customers. For instance, an improved cabin originally intended to be installed in the F-15 SE Silent Eagle modifications. The hybrid electronic mechanical counter all system was replaced by a more modern digital fly-by-wire control system, successfully eliminating the flutter modes that previously caused fighter stability problems, which caused earlier versions of the F-15 to disable 2 outboard wing pylons. It would be strange if, in pursuit of efficiency, the Boeing team worked on the appearance and engines of the aircraft, completely forgetting about the digital guts of T-EX. Therefore, it received a new mission computer, an advanced display core processor, and 2 large aviation displays for the pilot and weapon systems officer. An equally important role in the update was PL aid by the new ESA radar APG-821 from RON, which combines the ESA APG-633 antenna with the APG-79V processor to prevent all these components from overheating and malfunctioning. The fighter received a new cooling system and radio frequency filters, ensuring the simultaneous operation of radar and electronic warfare when integrated with the A. Q250EA or Eagle Passive Active Warning and Survivability System TH. E. Eagle II's large lifting capacity gave it an appropriate level of flexibility, a typical advanced Eagle configuration. Could carry 12 air-to-air missiles including short-range M10 AMRAAM or M9. Sidewinder missile. S as well as AGM at harm. The F-15EX can be armed with 16 AM. Rams 4A9S and 2 AGM-88 harms for precision striking. It's capable of carrying 16 GBU-39 small-diameter bombs. 4M Rams won 2,000 pounds of joy. NT direct attack munition, 2 harms and 2 fuel tanks to provide additional firepower for the F-22 Raptor and F-35. Lightning II. The F-15EX can be equipped with several large munitions like the AGM-158 JSM or the smaller AGM-183AR. The first Eagle II was delivered to Eglin Air Force Base in Florida in March 2021, subsequently forming a test group from the first 6 fighters to support development and operational fly. GHT testing. The pilots were shocked to learn how much ammunition this thing could carry. The USA have responded to several questions concerning why they are investing in more of these formidable Eagle II des. Despite the upcoming NGAD, they explained that the F-15EX is essentially a giant missile truck, which is why it is highly desired. During the final days of 2023, the Air Force's 2 newest fighters, the F-15EX Eagle II jets, landed at Egan Air Force Base. These jets, equipped with various enhancements, are considered some of the most formidable 4th-generation platforms. The recent delivery of the EX-3 and EX-4 fighters brought new capabilities, including a cockpit pressure monitor or warning system and an ultra-high-frequency antenna for satellite communications, which were not present in the initial 2 jets of the Eagle II family. The Egan Air Force-based public affairs stated that the F-15EX had successfully met every challenge to date and is nearly ready for deployment. Lieutenant Colonel Christopher We Operational Flight Program Combined Task Force Commander also mentioned that the delivery of the new